Trust is the most valuable currency in cloud computing. When you move your critical workloads to a platform, you are handing over the keys to your digital life. You expect the locks to hold. You expect the vault to be secure. But what happens when the people building the vault admit they cut corners? There is a specific narrative emerging from within the cloud industry that challenges the assumption of inherent safety. A former Azure Core engineer has come forward to discuss decisions that fundamentally eroded user trust in the platform. This is not just a story about a single outage or a bug. It is a post-mortem analysis of how architectural choices, prioritization strategies, and communication failures combined to damage the relationship between a major provider and the developers who rely on it. To understand the gravity of this situation, we must first look at the core security mechanisms involved. In cloud infrastructure, we rely heavily on something called a hardware security module. This is a physical device designed to safeguard and manage digital keys. It is the ultimate authority on identity and encryption. There is also a trusted platform module, which is a chip embedded in hardware to ensure the system has not been tampered with. When these components fail, the foundation of security cracks. The former engineer revealed that specific architectural decisions regarding the handling of these failures created systemic vulnerabilities. Instead of building redundancy that protected the customer, the system allowed these security guarantees to be compromised in ways that were not immediately visible to the user. Here is the thing. When a security module fails, it should trigger an immediate transparent alarm. It should halt operations until the integrity is restored. But the analysis suggests that in the rush to deploy features and integrate new capabilities, validation was sometimes bypassed. This created a scenario where the platform appeared functional to the outside world, while the underlying security posture was degraded. For a developer running a financial application or managing sensitive data, this is unacceptable. It means the assurance of safety was an illusion rather than a guarantee. This technical vulnerability was compounded by a broader cultural pattern. The drive to prioritize rapid feature deployment and artificial intelligence integration over rigorous security validation led to a perception of incompetence. In the early days of cloud adoption, speed was the primary metric of success. New services were launched to beat competitors. But as the ecosystem matured, the cost of that speed became apparent. Users began to question whether the engineering teams were truly competent or if they were simply shipping code faster than they could verify it. This perception of unreliability is dangerous because it forces developers to second-guess the infrastructure they are building upon. Now consider the communication gap. Trust is not just about technical performance, it is about honesty. Critical failures in core infrastructure were often downplayed or delayed in disclosure. When a significant incident occurs, the immediate instinct for a large corporation is to manage the narrative. However, this approach fosters skepticism about the platform's integrity. If a user learns about a security issue from a former employee rather than an official statement, the damage is done. The community begins to operate on the assumption that the official story is incomplete. This disconnect between internal engineering realities and external communication creates a vacuum of doubt. The erosion of trust was not limited to technical failures. The combination of high-profile security incidents, aggressive layoffs in the cloud division, and the perceived overpromising of artificial intelligence capabilities has created a cumulative effect. When a company lays off experienced engineers while simultaneously promising that their new AI tools will solve every infrastructure problem, it creates a cognitive dissonance for the customer. Users question the long-term stability and ethical stewardship of the platform. They wonder if the company is investing in the future of the product or just selling a vision that does not yet exist. So, what does this mean for you and your architecture? This analysis translates these trust-eroding decisions into actionable architectural guardrails and migration patterns for critical workloads. The first step is to stop treating any single cloud provider as a monolith of trust. You must design for failure. This means implementing independent verification layers that sit outside the provider's control. You need to verify the integrity of your data and your keys using tools that do not rely on the same underlying hardware mechanisms that failed in the past. Second, you must demand transparency in your contracts and service-level agreements. If a security module fails, you need to know immediately. You need to build systems that can detect when the provider is hiding information or delaying disclosure. This involves setting up your own monitoring and alerting that does not depend solely on the provider's dashboard. Third, consider a multi-cloud strategy for your most critical assets. This is not about avoiding one provider in favor of another. It is about reducing the blast radius of a single point of failure. By distributing your workloads, you ensure that a decision made in one division does not compromise your entire operation. This requires a shift in how you architect your applications. You must decouple your data storage from your compute logic so that you can migrate one without losing the other. Finally, you need to advocate for verifiable security proofs. The industry is shifting towards demanding greater transparency. As a consumer, you should require proof of security posture rather than relying on marketing promises. This means asking for third-party audits and independent certifications before signing off on long-term commitments. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.